In the beginning, there was silence. A darkness so complete that even time seemed to hold its breath. Then, a spark, a shimmer of light dancing in the void. That was the moment everything changed. From that light came the stars, and from those stars came us.
Billions of years after that first light, humanity decided to decode the universe's oldest secrets. And so, we built an eye capable of seeing across time itself. The James Webb Space Telescope, a golden infrared sensing masterpiece. With a mirror so precise that it could detect the heat of a bumblebee on the moon. Its 18 hexagonal segments are coated in pure gold, not for luxury, though it does look fabulous, but because gold reflects infrared light remarkably well. Each segment is adjusted using actuators that move in increments smaller than a strand of DNA. Then there's the sun shield. 5 layers, each thinner than a human hair, stretching the size of a tennis court, protecting Webb from heat so effectively. It stays colder than 230 degrees Celsius, colder than the freezer you open at 3 a.m. looking for leftover pizza. From its perch at the second Lagrange point, a gravitational oasis, 1.5 million kilometers away, Webb has revealed galaxies forming when the universe was just 350 million years old. It has peered into stellar nurseries, like the Carina Nebula, showing towering walls of cosmic dust, shaped by intense radiation and gravity. It's captured stars being born, stars dying, and stars that have been shining longer than Earth has existed. Webb studies exoplanets by analyzing starlight filtered through their atmospheres. This technique reveals molecules like carbon dioxide, methane, and water vapor, the chemical whispers of distant worlds. Some planets have scorching lava oceans. Others may hold global seas, covered in eternal twilight. And a few lie in the habitable zone, where temperatures could allow liquid water, a promising hint for life. Webb even gave Uranus a makeover, revealing its rings, storms, and polar caps. With such clarity, that scientist joked it finally had its glamour shot moment. Each image Webb sends home is not just a picture, it's a time machine, a story from when the universe was young, and a reminder of how far curiosity can take us.
As telescopes reach deeper into the universe, something remarkable is happening much closer to home. Earth's orbit is becoming a living, breathing network, a technological constellation reshaping the way our world connects. This is Starlink. Thousands of satellites orbiting in synchronized patterns, gliding across the sky like cosmic fireflies that never get tired and never take a coffee break. Each satellite communicates using laser links, sending data between one another at nearly the speed of light. No cables, no cell towers. Just pure, uninterrupted beams of information, zigzagging through the vacuum of space. And this network reaches everywhere, villages deep in mountain valleys, scientists stationed in Antarctica, ships drifting through the Pacific, and even those remote places. Your mobile carrier swore they would cover soon. But Starlink is more than connectivity. It's a demonstration of precision. Each satellite has ion thrusters powered by krypton, yes, the same element that sounds like it belongs, in a Superman plot. These thrusters adjust orbits by mere millimeters, keeping each satellite in perfect position. Below them, reusable rockets lift more satellites into space. They launch, deliver their cargo, and return to Earth. By landing on robotic ships, with names like, "Of course, I still love you." Even the ocean barges have personality. The result is a sky that is no longer silent, a sky filled with technology, with movement, with purpose. A sky that belongs not just to astronomers, but to all of humanity. For the first time in history, we are building our digital future. Not on the ground, but above it.
Beyond Mars, beyond the asteroid belt, past Jupiter's swirling storms and Saturn's icy rings, there is a world unlike anything you and I have ever imagined. A world where rivers flow with liquid methane, where lakes shimmer under an amber haze, and where the air is thick enough that a human could almost flap their arms and glide, not gracefully, but somewhat impressively. This is Titan, Saturn's largest moon, a frozen time capsule, holding clues to the chemistry that may have sparked life on Earth billions of years ago. And soon, a bold new explorer will fly across its alien skies. NASA's Dragonfly, a nuclear-powered 8-rotor drone, designed to soar through an atmosphere, denser than Earth's, colder than Antarctica, and richer in organic chemistry than any world we've ever visited. Titan is special. Its surface temperature sits at around 179 degrees Celsius, cold enough to freeze nitrogen. Yet beneath this icy crust, and within its thick atmosphere, lie organic molecules, the same ingredients that once sparked the earliest chemistry of life on Earth. That is why Dragonfly is going, to search for the building blocks of life, in a place where nature may still be experimenting with the recipe. But first, Dragonfly must get there. Launched into space, sleeping for years in the dark, crossing billions of kilometers, before arriving at a world where sunlight is just 1% as bright as back home. A world where the sun rises as a pale orange glow, barely brighter than moonlight on Earth. Once it touches down, it will awaken, extending its legs, unfolding its rotors, and testing the alien winds of Titan, before rising into the air for the very first time. Flight on Titan is graceful, beautiful, almost dreamlike. Because the air is thick and gravity is weak, Dragonfly can carry heavy instruments and still fly with the effortlessness of a bird gliding through dusk. And it won't just fly once. It will hop across Titan's entire landscape, up to dozens of kilometers between landings, exploring dunes, ridges, ancient impact craters, and dark regions where complex molecules may be locked within the icy soil. One of its destinations is Selk Crater, a site believed to have once held liquid water, due to the heat of a long-ago impact. Water plus organic molecules plus energy sound familiar. These are the same ingredients that may have sparked the first steps toward life on Earth. Dragonfly's instruments will scoop up samples, analyze them for complex chemistry, and search for molecules that hint at prebiotic reactions, the early whispers of biology. It will listen to Titan's distant rumbles, using a seismometer to detect tremors beneath the frozen crust. If there is a hidden subsurface ocean below, Dragonfly may hear it. Its cameras will map the alien landscapes in crisp detail, capturing dunes shaped by methane winds, rocks sculpted by hydrocarbon rain, and the faint glow of Saturn, hanging like a ghost in Titan's sky. Imagine the first time Dragonfly lifts off. Its rotors slicing through Titan's thick atmosphere, dust swirling beneath it, the horizon appearing slowly. As it climbs higher and higher, imagine the silence, a world with almost no wind, no rustling trees, no sound except the soft hum of the rotors and the distant creaking of frozen ground. Every hop, every sample, every pixel of every image brings us closer to answering a question as old as humanity itself. How does life begin? Dragonfly isn't just a mission. It's a storyteller revealing the secrets of a world that looks like Earth's ancient cousin. It's a time machine looking backward 4 billion years to the chemistry that shaped our beginning. It's a promise that we will keep exploring, keep questioning, and keep reaching toward worlds that challenge our imagination. When Dragonfly takes flight over Titan, it will carry with it something more powerful than any instrument or camera or piece of technology. It will carry our curiosity.
While Dragonfly prepares to explore another world, humans are learning how to live above our own. China's Tiangong space station orbits Earth every 90 minutes, fast enough to witness 16 sunrises and sunsets in a single day. Imagine trying to keep track of your sleep schedule up there. To reach Tiangong, astronauts board the Shenzhou spacecraft, a capsule equipped with automated docking, so precise it can align 2 spacecraft, traveling at 28,000 kilometers per hour without missing a beat. It's like parallel parking in space, blindfolded during an earthquake. In Earth, flames form perfect spheres, fluids float like living sculptures, and plants grow in strange patterns as if they're trying to reinvent biology. These astronauts aren't just visitors, they are pathfinders, learning how humans can work, live, and thrive beyond the cradle of our planet.
One truth becomes clear. We are only at the beginning of humanity's greatest journey.